Okay, let's look at the type of problem we call a variation. Now remember, we looked at the language of a variation problem, and we said that if a varies jointly as h and e squared, then we can translate that as the variation equation. A varies jointly as means we're going to multiply a constant. So a is equal to, we write the k for our constant first, and we know we're going to multiply that now by h and by e squared. So that's the translation. And then for the first part of this, we pick up the values we're given for a, h, and e. So a is 144 when h is 4 and e is 3. So we still have our k and we have the square for our e. Let's do the math here. 144 is equal to exponents first. That's 3 squared is 9 times 4 is 36 times k is 36k. And now we need to divide both sides by 36. And we get k is equal to 144 divided by 36. Which is 4. Okay, that's part 1. So we translated, we substituted values, and we solved for k. Part 2 picks up here. Find a when h is 11 and e is 10. So we're going to repeat the translation. A is equal to k h e squared. And it says find a, so we're going to leave the a in the translation. We found k in our first step, so we're going to replace k with 4. The new information says when h is 11, we replace h with 11, and e is 10, we replace e with 10, and we make sure we square that. Okay, so now we have math to do here. So order of operations says we square before we multiply, so 10 squared is 100 times 4 times 11. 100 times 4 times 11. So let's take that. 100 times 4 times 11 gives us 4,400 or 4,400. Okay, and so the translation of the variation language, then the first substitution to solve for k, and the second substitution to plug in the k that we found in step 1 and the new information given. Then do the calculations. Alright, that's a variation problem. Now let's look at some application problems. Let's read through this one together. If an object is propelled straight upward from the ground with an initial velocity of 160 feet per second, its height h in feet t seconds later is given by the equation h is equal to negative 16t squared plus 160t. The question is, after how many seconds is the height 256 feet? So there are a couple of important things to do here. One very important thing to do is to write the equation given to us. So that's h is equal to negative 16t squared plus 160t. And remember that h stands for the height and T stands for the time in seconds. Okay, T seconds. Okay. Another important thing to do is to sketch a picture of what this might look like. An object is propelled upward from the ground, so if here's a spot on the ground, an object is propelled upward, then we need to think through this. If we shoot an object upward into the air, what do we know also happens? Well, it comes back down to the ground, right? So there's sort of a picture of what's happening here. And it's important to think through this picture because that tells us that the object could be at the same height many times, couldn't it? Or twice. It could be at the same height twice, once on the way up and once on the way down. So it's possible that we would find two values for seconds where the height is 256 feet. It's possible. Okay, so we want then to substitute information that we're given. So after how many seconds is the height 256 feet? So we want to substitute 256 in for height. 256 is equal to negative 16 t squared. Now we're looking for seconds, so we do not replace the t variable, which stands for seconds. Okay, now the equation that we have here looks quadratic because of this. So because it's quadratic, let's put it in standard form. And we could move everything to the left or everything to the right. I'm going to choose to move everything to the right. That means I'll be adding 16t squared and subtracting 160t. And that will put everything on the left. 16t squared minus 160t plus the 256 that's already there is equal to 0. Now it's in standard form. Now I would see if I could factor out a greatest common factor, and the smallest number is 16, and if you'll try in your calculator you'll see that 16 factors out of all three terms, giving us t squared minus 10t plus 16 and is equal to 0. Now we could divide both sides by 16 and have only t squared minus 10t plus 16 is equal to 0. Now we could try to factor this trinomial. So t's for t squared and numbers that multiply for 16 and add for negative 10. Well, we try 2 and 8, and we need to know that because they multiply positive but they add negative in the middle, they have to be two negatives. So you could check that, multiply that out, make sure you get this back. But that's the correct factoring. Now we need to use the zero factor property and say that each of those factors could be 0 for a result of 0. And we need to add 2 to both sides here to solve. That gives us t equal 2. Add 8 to both sides here. It gives us t equals 8. So this says that there are two possible results. That the object could be at the height of 256 feet at 2 seconds and at 8 seconds. So maybe the 2 seconds should be on the way up, and then after 8 seconds it's on its way down, but it happens to be at the same height twice. Let's look at this application and see what kind of setup we need here. It says about 7 out of 10 people entering a community college need to take a refresher mathematics course. If there are 910 entering students, how many will probably need a refresher mathematics course? So the first numbers they give us are 7 out of 10. If we write that as a fraction, let's make sure we label what those numbers stand for. 7 out of 10 people entering a community college. So the 10 is people entering. 7 of those need a refresher. I'll just abbreviate that. Okay, so that helps us read carefully the rest of the way. If there are 910 entering students, so that tells us 910 goes in the same position as 10 over here. How many will probably need a refresher course? Well, that how many says we don't know that. But because we have two equal relationships here, or ratios, we can set this up as a proportion, and we can solve by cross multiplying. So 10 times x is 10x. 7 times 910, let's see what that is. 7 times 910 is 6,370. And then if we divide both sides by 10, that will isolate x, and it gives us x is equal to 637. Okay, so we see if that makes sense. 7 out of 10 is a large portion here, and 637 out of 910 is another large portion. Okay. All right, let's look at this application problem. Sally can paint a room in 4 hours while it takes Steve 5 hours to paint the same room. How long would it take them together to paint the room if they worked together? Okay, so this is a combined work problem, and we talked about this in class as setting up similar to distance, rate, and time. Rate times time equals distance. Well, in this case, rate times time equals amount of work done. So we could say rate times time equals work done. And we're also keeping up with two people, Sally and Steve, so we could put Sally here and Steve here. And then we said, we discussed in class how to figure out their rate. If Sally can paint the entire room in 4 hours, what is her rate of job per hour? Well, in 1 hour, she could paint 1/4 of the room. It takes her 4 hours to paint the whole room. After 1 hour, she's only painted 1/4 of the room. Steve, takes him 5 hours, so after 1 hour, he's only painted 1/5 of the room. So Sally's rate is 1/4 room per hour, or 1/4 job per hour, and Steve's rate is 1/5 job per hour. Now the time we're looking for is the time it would take them to work together. So we know their individual times, but we don't know their times together. So we'll put an X there for their time together. We don't know what it is, but working together, they'd be working for the same time. Now we want to show the amount of work that they each do. So Sally, rate times time would be 1/4 X. Steve, rate times time would be 1/5 X. And now we have to remember the key to these kind of problems is that the combined work, the equation 1/4 X plus 1/5 X, okay, that's Sally's amount of the combined work and Steve's amount of the combined work. When we add their parts together, we get one complete job. Okay, we have to remember that part of the setup for these. Now we have an equation with fractions, don't we? So we need a least common denominator to clear the fractions. For 4 and 5, the least common denominator is 20. So we're multiplying 20 times 1/4 X plus 20 times 1/5 X is equal to 20 times 1. Okay, so what that does here is this allows us to cancel. 20 over 4 cancels to 5. 20 over 5 cancels to 1. And there's no fraction here, so there's no cancel. So we're now multiplying 5 times 1 times x, 5x, plus 4 times 1 times x, plus 4x, is equal to 20. And we collect like terms here for 9x is equal to 20. And we divide both sides by 9 for x is equal to 20 over 9 is a simplified fraction. But in terms of hours, we might want to see that some other way. That we could say that that's 2 hours with a remainder 2, so 2 2/9 hours. And we could approximate. It wouldn't be a very nice decimal number, but if our directions said round to a certain place value, we could do that. Okay, but we know that the time together, 2 2/9 hours. Now we should look at that to see if it makes sense. If it takes Sally 4 hours by herself and Steve 5 hours by himself, then working together they should work faster than the fastest person works alone, right? Sally works faster in 4 hours. 2 2/9 hours is faster than either of them alone.